Hello everyone, my name is Saurav and today we will be discussing about my another project which is mostly offline and private AI assistant. Using this app, you can do small things like making call, setting alarm, playing song and few other tasks. What's most interesting is that all of these can be done while being offline. I mean, your data will not go to any AI server, but it will stay in your device. Only when you ask some general question like what's the best food in Croatia, then your data will leave your phone. Again, that is under your control. You can decide which AI server to use. So stick around and I'll show you everything step by step. When you talk to an assistant like Google, Siri, or Alexa, they use their huge server to process your question and check what's asked. So this was the primary challenge for me, and I used a TensorFlow Lite model, which can classify text into different categories within phone itself. My app can perform 7 different tasks, starting with making call, setting alarm, setting reminder, playing song, navigation, weather report, and last, answering some general question. So this is how flow of application looks. User asks question that goes to on-device model for classification. Based on the result, particular command is executed. Simple. I used MobileBERT model, which is part of BERT, used mostly in text-related work like text classification or generating new random texts. Getting a functional model was an 8-month education in pain. I started with zero machine learning experience, trying to fine-tune a model on 10,000 unique dataset per category. I gave 5 full training attempts over Google Colab, tweaking different settings like epoch or trying different set of data. Initially, I started with 100 unique commands for each category and thought this will work, but it failed. So after some research, I understood that I need to increase training dataset. But that's another challenge. There is no such dataset available which contains command like these. Now in pain, I decided to get synthetic data for training, which means I will generate it instead of obtaining from somewhere else. Again, BERT was a huge lifesaver as it helped to generate random unique text. Take example of navigation. I first generated 100 unique ways to ask an assistant to start navigation. Then I decided to replace variable places new with different unique places, which were again generated by BERT only. Combining all such techniques gave me 10,000 unique commands for navigation category. Finally, I was ready with 70,000 unique records for training my model. I'll put links in the description for this dataset and Colab notebook. Then comes fine-tuning. My initial attempts with TensorFlow Lite model maker failed. It was not working as expected. Then I switched to MediaPipe model maker. Now I was ready with final model, but it was not sufficient to be used on mobile devices. I had to go through another step called post-training quantization, and by converting the model weights from 32-bit floating point to 8-bit integers, reduced model size to 25 MB. Yes, you heard right, 25 MB. An AI model having size of 25 MB only. Integrating this on Android is simple. Just follow documentation and your model is ready for use. Now before I move to final step, I want to discuss about offline translation. I used Google's ML Kit, which provides an offline translation capability. This made my app multilingual with reduced latency. Now, of course, translation happens word by word, which might sound odd sometime, but it's good for small 1-2 line sentences. Here's how the whole process works. You ask a question by speaking in your own language. Your voice turns into text. That text is translated into English using Google's ML Kit. The English text is sent to our offline AI model, which figures out what type of command it is. Based on the command, an action is performed. You get a response in English. That response is then translated back into your language. And finally, Android reads it out loud for you. And this takes around 500 milliseconds to 1 second, which is perfect for an assistant-like behavior. I hate to compare this app with anything because when I started, Google's Gemini was noob, but these days, Gemini is like superpower. But still, in some cases, my app is more secure and much faster. Take example of making call. Gemini will take at least 1 to 2 seconds, while my app does this within milliseconds, still keeping all your data within your phone itself. Call Anand. Call Anand. This was a huge learning for me, stepping into AI applications. And who knows, we can even migrate this from Android to Raspberry Pi based mini home server to make a home assistant. Till then, thanks for watching and see you later.